Hi, my name's Fred Zelt. I'm a geologist and cyclist living in Pittsburgh, and I'm here to record a talk about geology of Western Pennsylvania and adjacent areas, focusing on the Ohio and Allegheny River drainages. Let me get my screen shared and get the presentation going. Here we go. And this is part of a series of rides, provides backgrounds for those. The rides are brought to you by Venture Outdoors and Earth Science Excursions. They'll be held here in 2022. And I'm recording this in April 2022. These rides covered by this talk are shown in blue here. They're part of a series of rides on each of the 25 bike trails longer than 10 miles in Western Pennsylvania, adjacent West Virginia and Ohio. You can see the list here. The series starts at the end of April. It ends with the Wilds weekend in mid-October. So 25 of these rides. And you can see the string of pearls shaded in blue on the map along the Ohio River Valley and also the Allegheny River and its immediate tributaries. So we've grouped these into 6 series of talks I plan to create and share. This is the first one I'm creating, the Allegheny and Ohio River Valleys. You can see the others. There's a different theme for each one, so there will be different content for each. So I'm not going to talk about the geology of the whole region in this talk, but I'll really focus on the river valleys, and each of the other talks will have a different focus. And we're sharing these both as background for people who ride with us on the Venture Outdoors bike rides, but also for anyone who might want to ride these trails. We're not sharing this to promote our Venture Outdoors rides on these trails. They're almost all sold out at this point. So really the purpose here is to share geology of Western Pennsylvania and the region, and also highlight the many great bike paths that are in our areas and some of the unique features of the region that relate to those paths. So the 9 bike trails, major bike trails covered in this talk and along the Allegheny and Upper Ohio Valley: Oil Creek State Park, Samuel Justus Trail, the Sandy Creek Trail. For some of my friends, it's their very favorite in Western Pennsylvania. Allegheny River Trail, it's a great trail. The Redbank, Armstrong, the Butler-Freeport Community Trail, another lovely trail. The Three Rivers Heritage Trail, I just led a full moon ride there. It's great both in daytime and in the evening to see the city lights. The Wheeling Heritage Trail and adjacent Brooke Pioneer Trail going up to Wellsburg. So those are the 9 bike trails that are grouped together in this theme of river valleys. The objectives of this presentation are to help people who watch it understand better the regional and local landscapes and how those relate to the geology, and to increase awareness of natural resources that were important in the early development of the region. So the agenda to get there through the presentation, we'll talk about glaciations, how the river systems were amalgamated and rerouted as a result of the glaciations. And as part of that, there were drainage divides that were breached and made really special narrow valleys that are especially scenic. We'll talk about ancient river terraces that are perched above the current river levels along the valleys. And we'll talk a little bit about sediment underneath the rivers, and have a little focus on the Pittsburgh subway tunnel under the Allegheny. And then there's a section at the end with an overview of natural resources that were especially important to the early industries here. Natural resources will be a bigger focus of the geology talk that covers the plateau rides. So on with the talk. This is meant to indicate potential thickness of glaciers during the last glaciation. A peak of it was about 18 to 20,000 years ago. And you can see this map shows thickness in meters. So the red box and pointer indicate the thickness of glaciers around the southern shoreline of present-day Lake Erie is thought to have been about 1,000 meters, more than 3,000 feet thick there, and even thicker farther north in Canada. So those were certainly very thick glaciers, and as you'll see, thick enough to stop and turn around rivers that were heading into the north, into the area that the glaciers eventually overrode. And surely the earlier glaciers were similarly thick. This is a map showing the extent of all the glaciations in the last couple million years or so in the lower 48 of the US. Of course, there were continental scale glaciers in Europe and Russia too, that are like the ones in Canada, gone now. Of course, there are still continental glaciers in Antarctica and Greenland, and the glaciations will be a bigger focus of another theme talk. But for this purpose, look at the Ohio River here that traces the southern boundary of Ohio, Indiana, and Illinois. And you can see that it's just in front of the maximum extent of glaciations. So that river location was really shaped by the glaciations, and that'll be a key theme of this talk. You'll notice that there were glaciations both in northeastern and northwestern Pennsylvania. We'll really be focusing on the western Pennsylvania region. This is a summary of what's thought to have happened with the drainages. The pre-glacial drainages are on the left, and then the extent of glaciers is shaded with the post-glacial drainages and drainage directions shown by arrows on the right. So turning to the left here, you can see the Alleghenies thought to have been in three different pieces, upper, middle, and lower. And the upper Allegheny and middle Allegheny, each of those is thought to have drained to the north originally. There would have been drainage divides to the east and west of Warren. There would have been a drainage divide north of Oil City here, a drainage divide north of Parker, separating these parts of the Allegheny River. And then the Monongahela River was a large river system that flowed past where Pittsburgh is, along what's now the upper Ohio River, up the Beaver Valley, draining to the north. And the upper Ohio Valley is actually thought to have been a tributary to that Monongahela River system. But when the glaciers came and were so thick, as I mentioned before, they forced these drainages to reroute themselves. These former drainage divides were breached, and the whole system ended up draining to the south, as it does today along the Ohio River into the Mississippi. So that's an overview, and we're going to look at some of the details here and where our bike paths are located in this context. When the glaciers came and plugged up the river drainage to the north, they're thought to have created one or more large lakes filling river valleys. This is so-called Lake Monongahela. There are clay-rich sediments of glacial age that have been found in lots of these river valleys from this glacially caused lake. The spill for it's thought to have been in the Ohio Valley around New Martinsville, West Virginia. The lake would have covered Clarksburg, Morgantown. Of course, Pittsburgh would have been covered. The top of it was 1,100 feet, which is about 50 feet below the top of Mount Washington. So a pretty extensive lake system. It even flooded up into the Allegheny River Valley as far as Indian Creek or Camp Carmel. And it was there that geologists from Lehigh University, professor and students did some age dating of those lake deposits. And they found that those deposits indicated an age of the lake of 1.8 million years ago during this period of glacial interglacial cycles that have been happening the last 2.6 million years. So a pretty extensive lake, complex history, though it might not have been the only lake that was there. This shows a proxy for temperature. This is from stable oxygen isotopes, a reliable indication of temperature. These isotopes come from small marine fossils, the shells of small marine animals. But for the last 800,000 years or so, there's a similar record from ice cores from Greenland and Antarctica. It shows the same thing. So the cooler periods were glaciations. This is that last glaciation. It was at its maximum 18 to 20,000 years ago. We're in an interglacial period now. Sea level, as those thick glaciers in Canada and Northern Europe and Russia melted, sea level rose something like 120 meters coming out of the last glaciation. Since Lake Monongahela 1.8 million years ago, there have been about 30 alternations between glacial and interglacial periods, about every 100,000 years for the last million years, and then about every 41,000 years before that. And I'll talk more about those cycles in the talk that focuses on glaciations. So certainly it's a very complex history, even since the formation of Lake Monongahela. Now let's look at what's happened with the drainages. And this is an elevation map. We'll see a whole series of these. The color bar on the right indicates elevations in feet. The red colors are higher elevations. The greens are lower. You can see the lake plain here. There's Presque Isle, actually, where one of our bike rides will be. So a low, flat lake plain. And then these upland areas with rivers incising into them. You can see the rivers in the yellow elevation colors. The arrows are in the direction of present day river drainage, but the blue arrows are places where before glaciation, the rivers are thought to have drained in the other direction. Those valleys drained in another direction. A good place to look at that is up around Warren. You can see tributaries to the main stream valleys here. The tributaries point downstream. Everything's good there, but it really looks like this stream and river actually flowed to the north through here and met up with another one and flowed off to the north. Similarly, this one is thought to have flowed to the north with a tributary coming from here, and that this is a drainage divide, an upland area between those stream or river systems that was breached in glacial times, and the Allegheny River has cut through that. You can see how much narrower the river valley is here east of Warren than it is in these older valleys that had more time to broaden and erode. So a younger, steeper sided valley. Same thing on the other side of Warren, another breached drainage divide between rivers and streams that originally flowed in other directions, and this upland area is interpreted to have been breached. This narrow valley was actually used to site Kinzu Dam, a relatively small area that it had to be constructed across the valley where the valley is narrow. And then it impounded the reservoir here where the valley is much wider and older. So the reservoir has a greater capacity than it would in a narrower valley. Continuing then down the Allegheny River, there's Oil City, here's Titusville, this is Oil Creek. And this is another place where this drainage system before glaciers came is thought to have drained through Titusville and up to the north. And that when glaciers came and forced a reorganization of the drainage, this upland area was cut through. So there's a relatively narrow valley here in Oil Creek State Park. And it's a nice scenic area. Here's Franklin. Here's Emlenton. This is another interpreted highland drainage divide between different segments of the Allegheny River, which then were amalgamated as the river cut through this area. And again, this is an area just north of Emlenton where the Allegheny River is relatively narrow. So those are especially scenic areas. These are our bike rides along the river valleys here. And you can see in these drainage divides indicated by the lines here. Here's Oil Creek State Park, and this is the part of the Allegheny River Trail that will cycle north of Emlenton. We'll also cycle the Sandy Creek Trail here. It's a very scenic, nice tributary to the Allegheny, and then along the Allegheny, the Samuel Justus Trail. Let's look at another part of the river system farther downstream. Here you can see Pittsburgh, the Three Rivers Heritage Trail is located here, and then the Wheeling Heritage and Brooke Pioneer Trails here. So this is the Monongahela River drainage, flows to the north. and it's thought to have originally flowed up the Beaver Valley, and that this part of the Ohio River was actually a tributary to it, but that when glaciers came, they forced reorganization and forced this river system to turn around and flow to the south. This is a bigger picture view. Here you can see Pittsburgh and Wheeling, and this is a view of drainages before glaciers came, with maximum extent of glaciations indicated in the lavender color. And this is that drainage divide between these north draining parts of the Monongahela and now Upper Ohio system into the Beaver Valley, and then another really large river system, the Terrace River system, as it's become known, which incorporated part of the Kanawha, part of the current Ohio Valley, and that's a system we're going to look at in more detail. Again, a drainage divide around the location of New Martinsville here. The reason we're going to look at this part of the drainage system is because it's important to understand that, to understand why the rivers here in Western Pennsylvania and surrounding area cut down so much. So here's a map of extent of glaciers. It's the shaded area. And this time we've overlain the trace of this large Terrace river system. And then we're also showing a map of glacial deposits in Ohio that we'll come to in a minute. So there's the Terrace river system. It actually is the new river that drains the Blue Ridge in North Carolina. So it cuts across the grain of the Appalachians with the new river. It used to flow near Columbus in central Ohio, across Indiana and Illinois. So it's an extensive, large river system. One of the headwaters was here. There's that drainage divide I mentioned near New Martinsville. There's wheeling so that you stay oriented. But when glaciers came, just like we talked about in Pennsylvania, the Terrace river system couldn't drain to the north anymore. It was overrun by glaciers. And to help visualize that, this is a map of glacial deposits in Ohio on top of solid bedrock, the bedrock being hundreds of millions of years old, these glacial deposits being tens of thousands to hundreds of thousands or a few million years old. The older glacial advances came as far down as Cincinnati. The oldest glacial deposits are shown in the brown colors. These green shades indicate deposits from the youngest glacial advance. Specifically, these medium green areas are low ridges where, as it retreated, the glacier paused there for a while, carried sediment down to its snout where it melted, left a small ridge of sediment there before it retreated again, retreated again, retreated again. So you can see the advances and retreats of these glaciers, and you can imagine that the younger glaciers overrode the deposits of the older ones and largely erased them. The blue are glacially related lake deposits. These are from an ancestral lake of Lake Erie. Lake Erie's been both higher and lower than today. But these blue deposits are from a lake that filled in the Terrace River Valley. This is part of the Terrace River Valley here in southern Ohio. So we'll see a bit more about that. Just to firm up evidence for the Terrace River in Ohio, this is thickness of glacially derived sediment. And you can see the shape of the now buried Terrace River Valley. It was buried, overrun by glaciers. Here's where it's in front of the maximum extent of glaciers, but it's a valley that was once as much as 400 feet deep, as high as the current Ohio River Valley, going across a part of Ohio that's really a very flat landscape today, but has this buried ancient river valley. This map shows these glacial lakes that I mentioned. Here's Lake Monongahela that I talked about previously, the stars indication of the location of Wheeling. And this is so-called Lake Tight that was dammed by glaciers that came down into Ohio and overran the Terrace River system. So these are both very large glacially caused lakes with a drainage divide in between. Lake Tight is thought to be older than 700,000 years, maybe as much as almost 2 million years old. It hasn't seen the kind of direct age dating that's happened, at least in one spot, for Lake Monongahela. So it's not known whether those lakes existed at the same time or at different times, but they certainly have a similar cause. Now let's talk about ancient river terraces along the valleys. And let's move back up the Allegheny River here. This is Interstate 80 at the top of the chart. There we go. There's Interstate 80. There's Emlenton. One of the bike rides, the Allegheny River Trail ride, starts and ends in Emlenton. This is the Clarion River, the Redbank, and the Redbank Valley ride will be along here. And you can see the Allegheny River Valley here, as I mentioned before, is very narrow. This is an interpreted breached ancient drainage divide. It's really scenic because it's so narrow here. And the valley widens out quite a bit. There's an inner gorge of the valley, and then there's an intermediate level where there's a perched river terrace. And this river terrace goes up the Clarion River, it goes up the Redbank River. Those are ancient river valleys that were part of this part of the Allegheny system. But I wanted to call your attention, the town of Parker, Pennsylvania is here, and look at this shape opposite the current Allegheny River in Parker. This is, you can see that the ancient Allegheny here carved edges to its valley before the whole river system cut down and left those terraces, those ancient river terraces or ancient river deposits high and dry. Let's look at a little closer at the one in Parker. And the reason I want to emphasize this one is partly because it's such a great example. You can clearly, I think, imagine the ancient Allegheny River having gone around a loop here. But it was so obvious that it was well studied by geologists in the late 1800s, early 1900s. So it's a surface of regional significance, this major terrace surface. The name Parker Strath, Strath being the bedrock bottom of this terrace, the Parker Strath is a named feature for a prominent river terrace level in Ohio, West Virginia, Kentucky, even Tennessee, and then down the Taze system into Indiana and Illinois. So Little Parker, Pennsylvania has a name that's well known among geologists who've studied those ancient river systems because this is such a clear feature and was studied so long ago. You can see that there are streams incising into that ancient terrace. That's another feature of the landscapes here, as the whole system has cut down a couple hundred feet or more since this terrace or the river was at this level. I've had a chance to visit here and looked at, found river-rounded pebbles, cobbles, and small boulders that used to be at the bottom of the ancient Allegheny River here, maybe hundreds of thousands of years, maybe even more than 1 million years ago. And most of these rocks are sandstones that are locally derived from the walls of the valley, but some of them are crystalline rocks. Like this is a granite or a gneiss, a crystalline rock that was carried by glaciers down from Canada, where that occurs in bedrock, and then washed into the river system. So you know that glaciers were active at the time that this river deposit was laid down, which is now perched more than 200 feet above the current level of the river. Let's look now at a terrace around Freeport, and this is where we'll cycle the Butler-Freeport Community Trail. So here's the town of Freeport on this elevation map. We'll actually meet in Laneville, across the river from Freeport here, and go up Buffalo Creek and then Little Buffalo Creek. But across Buffalo Creek from our meeting spot in Laneville are some terraces. The high terraces have these river-rounded sandstones and quartzites, very resistant to erosion, probably very old terraces. And then a little farther down are younger terraces. And this one includes, again, rocks that were carried by glaciers down from Canada. They're granites and high-grade metamorphic rocks, gneisses, carried down from Canada and then washed into the Allegheny River here and deposited in this high terrace. And then since then, the whole river system is cut down more than 200 feet to its current level. Let's look at one of those that's near Pittsburgh, a really good example. And I hope here you can see the Allegheny River, the Monongahela forming the Ohio. There's the Youghiogheny. And if you look closely, you'll see in yellow some perched terraces. Here's one from the Youghiogheny. Here's one from the ancient Allegheny River. There are a lot of other ones along the Allegheny too, and along the Ohio. Here you can see flat ground that's an early development area along this part of the Ohio, well above the current floodplain, so a great place to settle and an early development. But look at this one. We'll take a good close look at this one that's right around Pittsburgh. So here's a close-up elevation map. The yellow oval indicates our North Shore ride on the Heritage Trail here. We will go by Troy Hill, which is the same level as this. It's also a perched, flat-topped river terrace, but this one's about 1 mile wide. Clearly, the ancient Monongahela River used to flow here, and then since the river cut down such a large amount when the whole river system here was reorganized, these streams have started to incise into this flat terrace. This terrace runs from Swissvale past Wilkinsburg. This is why East Liberty is so flat. It goes around through Oakland too. This is 9 Mile Run, and then a tributary to that is Fern Hollow. And in the next view, we'll look at some of the river terrace deposits at the top of Fern Hollow here. So here's the top of Fern Hollow, flat-topped terrace top is the top here. These are 200-plus-year-old trees, and embraced in their roots are ancient river terrace deposits, sands, and these river-rounded pebbles, cobbles, and small boulders. You can see a mason's hammer, a rock hammer for scale here. They're all sandstones. They've come from the south, from the Monongahela River drainage, so there aren't glacially carried rocks from Canada in these ancient deposits of the Monongahela River on that terrace, quite a bit above the current river level. Next, we're going to look at a slide series that's going to come around to focusing on some really beautiful terraces in the Crafton Ingram area. And the reason I'm focusing on this is because I want to get across the point of what happens with tributaries, not just the main river system here cutting down so much, but what happens to the tributaries through time as this river system cuts down. So to start off, here's an idealized stream elevation profile. Elevation on the vertical axis, horizontal distance on the bottom axis. So here's an upland area. You can imagine an ideal stream profile with a smooth profile coming down to base level, maybe a stream coming into the sea or into a lake, or maybe a stream coming into a major river. But if that base level drops, if the stream or if the river drops, river level drops, for example, the lake or ocean level drops, then erosion starts working its way upstream, and the stream tries to establish a new equilibrium profile, another new smooth profile, but that erosion works its way upstream. Here's an example of this in progress. This is from Mingo Creek, a tributary of the Monongahela, and this is from a recent master's thesis at WVU. Here's the elevation of the current Monongahela River, and this is an elevation profile on the stream bed of Mingo Creek. You can see it's a fairly steep stream bed. It gets less steep here, and this is thought to be the ancient river profile, which may have been an equilibrium profile for the ancestral Monongahela River when it was much higher, maybe relating to one of those major terrace levels. Since then, the Monongahela has cut down quite a bit, and then there's been erosion in the lower part of Mingo Creek, and the nick point here is the boundary between that really active erosion and the older landscape, the older stream profile. So that's a nick point, and this is actually about the upstream edge of Mingo Creek Park. is the actual location of that. So an old landscape upstream here, a younger incision. There could be terraces and benches left behind on the stream valley here as it cut down through time. And there could be lots of cascades and waterfalls of this tributary or other tributaries here because of all this erosion. Another effect this has is in terms of power, water power. So not only do we have scenic cascades and waterfalls in places in our region because of this incision, but also water power for early industries because of the elevation changes caused by this incision. Now let's look in the Crafton Ingram area, another elevation map. Here's McKee's Rocks. There's the present-day Ohio River, and this is Chartiers Creek heading its way up toward Washington County. The colors here again are elevation, the upland area here in the reddish colors. Clearly there's a really nice river terrace level here in Crafton in yellow on the elevations. The green elevations here are another major river terrace. You can imagine the ancestral Chartiers Creek having cut the edges of this terrace and then cut down to its present level in the blue elevation colors. A little bit closer look at this and a couple of example elevations for the green colored and the yellow colored terraces. And then we're going to look at those on an elevation profile, again, from this master's thesis done a couple of years ago, completed a couple of years ago at WVU. Here's the present elevation of the Ohio River. And this is Chartiers Creek elevations going up into Washington County. And again, you can see this smooth profile in the upland area south of Washington Crown Center, which appears to be the nick point or the boundary between erosion that's working its way upstream after so much incision of the and deepening of the Ohio River Valley. And you can imagine this terrace having been in an equilibrium stream profile with that upper upland area. This one, a younger terrace, as Chartiers Creek was forced to cut down as the Ohio River cut down, and the whole system eroding farther upstream. So a little background then on terraces and tributaries and how that relates to some important aspects of our region, not only scenic, but in terms of early industry too. Let's look now at a big chunk of the Monongahela River system and then the Upper Ohio. The next series of slides is going to be a profile showing a history of river terraces on this whole system. And I'll just remind you that between Pittsburgh and Wheeling is the Beaver Valley, where at one time the whole system here is thought to have drained to the north, but then glaciers came and forced it to reorient itself and drain to the south. So this will be a whole series of slides along that transect from the Upper Ohio Valley here past Wheeling up to Pittsburgh, and then down the Monongahela River past Morgantown into West Virginia. And the authors here identified river terraces, and each terrace, the elevation of each terrace is shown by a vertical line here. So this is a lot of information on one chart. The present day river level is indicated by these horizontal lines. There are pools separated by dams. The base of the river system would be below that, but there's the top of the current rivers. So a whole series then of terraces were identified by these authors, and they also put together information that was compiled by others, not only themselves, but others too. And they're showing where there are these fine-grained clays and silts deposited on these terraces where there were lakes. So these are the deposits of Lake Monongahela. These are the deposits of Lake Tite that I showed on a previous map, a much lower elevation than the lake deposits for Lake Monongahela. Let's look now at a series indicating a time series here of these terraces. So the oldest terraces on both sides of that drainage divide around New Martinsville are relatively flat terraces. So a low gradient, not a steep river system, probably a pretty mature river system. And the river system here is that Monongahela River system, with this part of the Upper Ohio feeding into it and feeding to the north then up the current Beaver Valley. So that's that really old perched river system. This is an old river system feeding into the Taze River as well, with an upland area separating them. This is the maximum elevation of Lake Monongahela, 1,100 feet, mentioned before. This is about the upper elevation of Lake Tite. It's a lower elevation here. We don't know the age of Lake Tite with precision. We only have one age date so far for Lake Monongahela, and it may have had a complex history. That was 1.8 million years ago. The ages indicated for Lake Tite, again, were between 700,000 years and maybe as much as close to 2 million years ago. So they could have been at about the same time, but that's not known yet. And actually, Lake Monongahela may have been deeper than this indicates, but it was likely at least this deep. And the interpretation I'm showing is consistent with the interpretation of the authors who really studied this in a lot of detail. The next terraces then, the next terrace is this one, indicating still this part of the Upper Ohio Valley was draining toward the Beaver Valley, draining to the north, not to the south. But then by this series of terraces, this drainage divide had been breached. And so this part of the Ohio Valley had been integrated. It was draining to this, to the south, to this much deeper drainage. We're starting to cut down a lot here in the Wheeling to Pittsburgh area. By the time of this terrace, a lot more incision. You can imagine a nick point working its way upriver through time here, a deeper terrace, and then the youngest glacial age terraces are down here. And we'll talk in a little bit about what's below river level, that actually bedrock here below river level would have been cut some time ago, not in the very recent past. And just for scale, this is 200 feet in scale. These terraces are really important for development. For example, Steubenville uses these terraces. A lot of the towns along the valleys use these terraces. They're great places to build because they're flat ground in an area that just doesn't have much flat ground, and they're well above the current floodplain, so they're not susceptible to flooding. So they're important for the development of our area, and a lot of our bike paths go along the lower parts of these river terraces. I mentioned sediment below the river channels. Here's another profile. This one goes from Pittsburgh down the Upper Ohio River Valley. The current river channel, the base of the river, the river bed, is a solid line here. And the dashed line is indicating the top of bedrock. So there's sediment between those two. This chart also shows the width of the Ohio Valley from Pittsburgh to the south. So you can see width in miles here of the river valley. It's a relatively narrow valley in this part of the system. It's especially narrow around New Martinsville here, where there's that interpreted drainage divide that was breached, that upland area that was breached, so that the Ohio River now flows through it. This older Taze tributary river system to the south is much wider, consistent with it being an old river system. Here's a close-up of the thickness between the bottom of the Ohio River and the top of bedrock. So there's sediment in between those two. It's about 20 feet of sediment right around Wheeling. And here you can see that in cross section. We're looking across the river around Wheeling now. There's the level of the Ohio River. And this is sand and gravel that's thought to have been washed into the river here a long time ago by glaciers. And then there's more recent finer grained sediment on top of that. So glacially derived sediment And the river level today, the bottom of the river isn't touching bedrock underneath. We're not eroding into bedrock today. Bedrock here would have been incised at some ancient and very different stage in evolution here, maybe at a time when there was a lot more water in the system from glacial outwash, or when the Nick Point was migrating through and we were having a lot of erosion here. But today's rivers aren't actively eroding down into the bedrock underneath, although the tributaries are, as we saw in the examples from Mingo Creek and Chartiers Creek. The tributaries are actively incising and trying to establish equilibrium with this deeper valley, deeper river valleys. Here's the same kind of cross section from Pittsburgh. You can see downtown Pittsburgh. We're looking from this direction with the north side here on the left, downtown Pittsburgh, and then the Monongahela River and south side on the right. There's bedrock in blue, hard rock that's hundreds of millions of years old, and then soft sediment on top. And these colors, the yellow and green, are meant to indicate sediment that would have washed into the river from glaciers. Lots of sand and gravel there coming down the Allegheny River from glaciers. Not quite as sandy in the Monongahela River channel, more finer grained sediments coming from the south there. But you can see the scale here. There's 50 feet as each division for scale. These sandy deposits underneath the rivers, it's easy to get water to flow out of those. If you put a shallow well into it and you pump, you can easily get water out of those. So that was an important source of early water, especially for industry. Of course, these valleys were heavily industrialized. And so those aquifers are quite a bit typically polluted now, but it was an important source for industrial water early on because you could get such a high volume of it in addition to getting water directly out of the rivers. Here's an approximate location of the subway tunnel underneath the Allegheny. One of our rides is along the Three Rivers Heritage Trail on the North Shore here. And we'll talk about the connector for the subway between downtown Pittsburgh and the North Shore. It goes under the Allegheny in about this position. So it goes through some of that glacially derived soft sediment, but also dips into bedrock too. To summarize then, effects of glaciers on these valleys, the whole Allegheny River system was connected up from segments into a larger river system. That connection to the south with the Ohio River system down there led to a significant deepening of all the river valleys, and it's worked its way up the side tributaries and stream valleys in this whole system. So a deepening then that's given the bottom parts of the valleys here. There are some special places where upland areas were breached as part of that reorganization of the river system. We'll be in two of those. Oil Creek State Park is one. The Allegheny River Trail north of Emlenton is another. They're especially narrow valleys with steep sides. They'll tend to have waterfalls and cascades on the sides. They're just great. And those scenic features are thanks to this evolution. The flat ground that was developed early in the towns and cities along these rivers was formed by river bottoms long ago and then perched as the rivers cut down. So those have been important in the development of the region and the locations of bike paths. And the bottom of the Ohio River is well above the bedrock valley floor. So the bedrock valley floor of the river systems from Pittsburgh down the upper Ohio was cut long ago, not by today's rivers, which are really lakes. The current rivers look bigger than they really are most of the year because they're really lakes held in place by dams, and they would look a lot smaller. So they're kind of underfit rivers to the size of the valleys they're in. The sandy valley floor below those hosted a shallow groundwater aquifer that's been important in the past too. The last part of the talk then is about natural resources, and this is just a summary. There will be a lot more about this in the talk about the plateau. Water was an important natural resource. We get lots of rainfall here, lake effect rainfall when the lakes aren't frozen over. So rivers, streams, springs, and groundwater important not only for drinking, but for industry. We talked about the power aspect of the combination of topography and abundant rainfall in early industry, powering early industry. One of the early industries being iron making. Often iron furnaces used water power to run the blast, to run the bellows that blew air into the furnace. But wood burned to charcoal was used as a fuel within the furnace, along with iron ore and limestone for making iron. As the steel industry came along, coal, oil, and gas were important for fuel for that industry, as well as glass making and brick making, the other ingredients for making glass, local sands and sandstones, but also sandstones from the adjacent part of Pennsylvania, very high in silica, were great for glass making. We have an old glass industry here. And then lots of clays for brick making too. So there's one of the furnaces we'll see on the 25 bike rides. This is Rocklin Furnace. We'll walk up to this furnace in a side valley along the Allegheny River Trail. This one operated for 20 some years, produced 800 tons of iron a year. It used local iron ore and limestone from rock layers that were around the hilltops adjacent to the valley here. So gravity helped with getting those important ingredients down to the furnace. And the charcoal that was burned here, the furnace consumed about an acre of forest per, I say year, it's per day, an acre per day, not per year. Here's a map of Venango County, and there's the Rocklin Furnace location. There's Emlenton. There's the ride that we'll take from Emlenton up the river valley. And the triangles indicate iron furnace locations, and burning an acre per day of forest to make charcoal to feed these furnaces, assuming a little time off for part of the year, and that furnaces like the Rocklin might have operated for 20 some years, each one would have burned something like 12 square miles of forest. So you can imagine here then that these furnaces really were responsible for a lot of the deforestation of this part of Venango County, and in fact, for a lot of Western Pennsylvania. Those are our ride locations here, the Allegheny River Trail. This is the Sandy Creek Trail. There were furnaces along Sandy Creek as well. This is Franklin, and that's the part of the Samuel Justus Trail that we'll cycle. There's Oil City, and this is Oil Creek where we'll cycle. So furnaces around this part of the region. And feeding the furnaces, the high parts of hills in much of Venango County had the Vanport Limestone. This is an outcrop in another part of Western Pennsylvania in Lawrence County. So limestone was used in the iron furnaces, but also iron ore. There's commonly an ironstone on top of this more than 300 million year old marine limestone, the Vanport. This is where it's relatively thin. This is from near a quarry where the limestone is quarried for construction purposes. Typically, this ironstone on top is thin, but it gets up to 10 feet and in places even more than 10 feet thick. And there it was a good source for those early iron furnaces before railroads came in and brought in richer sources of iron for making iron and steel. There were other sources of iron ore too. This is one of the important sources, but other rock layers had other sources of ironstone and iron ore. We talked about energy resources. There's a map of coal extent in Pennsylvania. Of course, coals go into West Virginia and southeastern Ohio too. And here in southwestern Pennsylvania and adjacent areas, the Pittsburgh coal is consistently over a huge area, 6 or 7 feet thick. And here's an outcrop of Pittsburgh coal. There's the base of it. There's a shale underneath, a very soft, very clay-rich shale. We'll talk about shales like this that were used in brick making. So that was one of the resources. And then, of course, an energy resource right with it of coal here. So abundant coal as an energy resource. Oil and gas, too, as an early energy resource. Gas fields are shown in pink and red, oil fields in green. I'm pointing to Venango County here, the birthplace of the American oil industry. And we'll talk a lot about that when we are in Oil Creek State Park. But very widespread early availability of energy from oil and natural gas. And that legacy is continuing today with gas production from unconventional wells in the Marcellus and Utica. Marcellus production in northeastern Pennsylvania, southwestern Pennsylvania, going into adjacent West Virginia. And then also in this area and adjacent southeastern Ohio, from a production from a deeper level, the Utica Shale too. A closer view, there's Ford City, where we'll start riding on the Armstrong Trail, and on the Butler-Freeport Trail, we'll meet near Freeport. And if we make it up to this part of the trail, we'll talk a little bit about shale gas development, because you can see some of the signs of it along the trail in this area. So this is a very important source of natural gas for the US today, coming from this region from shale gas wells. This is a vertical column of various rock layers in the Pittsburgh area. The colors indicate different rock types. And I just wanted to point out a couple of them. These black layers are coals. There's the Pittsburgh coal, for example. The brick pattern is for limestones, either marine or non-marine limestones. And underneath and associated with some of the coals, the gray here indicates clay-rich shales. And some of those are fire clays that were used for making really high temperature brick, brick that could line furnaces and not melt at 3,000 degrees Fahrenheit. This is another especially clay-rich shale. And clay-rich shales like that could have been used for brick making. There are lots of those available, along with energy resources equals what the ingredients you need for making brick. And some clays that were deposited in the Glacial Lake may have been used for pottery too. So lots of clay resources. So that's it. Those are the topics we intended to cover, talking about the Allegheny and Ohio River valleys, the trails along here: Oil Creek State Park, Samuel Justus, Sandy Creek, Allegheny Redbank, Armstrong, Butler-Freeport Community Trail, Three Rivers Heritage, and the Wheeling Heritage and Brooke Pioneer up to Wellsburg. And again, this is one of 6 talks we plan to offer, covering the areas of all 25 major bike paths in Western Pennsylvania and adjacent states. So I hope you've enjoyed this. I hope you've gotten something out of this. And if you're not able to ride with us, I hope that you will find an opportunity to explore more of these trails yourself. That's part of the reason that we're creating this series and highlighting all 25 of these trails.